Hello students, how are you? So, I am assistant professor Karan Kumar Das, come back again to take your class. So, in last day we have studied up to the chemical property, just we have started the chemical properties of the alkene and we have studied by reaction of the halogen. So, today we have started the reaction of the halogen acids. So, first question, what are the halogen acids? From the name, hopefully you can understand halogen acids are the hydrochloric acid, hydrobromic acid. That means the acid contains at least one halogen atoms. Okay, hydrochloric acid, hydrobromic acid. So, when alkenes reacts with the halogen acids, it is the very simple. They form one alkyl halide. See, here I have given an example, the reaction of the ethylene, hopefully you can see it, the reaction of the ethylene with hydrochloric acid, with hydrobromic acid, and it is forming the ethyl bromide. Okay, it is also known as the bromoethane also, clear? So, it is the reaction of the alkenes with halogen acid. So, next question, what is the mechanism? Mechanism is the very simple, same like the addition of the halogen with alkene. Okay, first step, what happened? In first step, the hydrobromic acid, okay, the hydrobromic acid breaks down to the one electrophile and another nucleophile. Okay, the electrophile part is the H plus ion, that is the proton, and nucleophile is the bromide ion. Okay, the nucleophile part is the bromide ion, and next step is the same. The H plus ion, that means the electrophile part directly attack to the double bond of the alkene and forming the carbonium ion. Here it is forming the ethyl carbonium ion. Okay, the ethyl carbonium ion is formed. Okay, in the next step, the negative bromide ion directly attached to the ethyl carbonium ion and forming the ethyl bromide. It is the final product. Okay. Next, there is one thing can be happen in case of the reaction of the alkene with the halogen acid. What is the thing? Suppose if the alkene is the symmetrical, then there will be no issue. See here, I have given the examples in case of the ethylene. Okay, ethylene is the symmetrical alkene. Why it is symmetrical alkene? Because the hydrobromic acid bond, that means HBr bond, if react to the this carbon or this carbon, there will be no issue. The end product is the same product, that means the ethyl bromide in every case. But suppose if this thing will be happen in case of the propene, what will happen? See here, in case of the propene, if the HBr bond is react either to the H plus, that means the proton, that means the electrophile part will react either this carbon or this carbon. But in case of the this carbon, what will be happen? See there, in case of the A, isopropyl bromide will be found. But in case of the B, the normal propyl bromide will be found. But from the experiment, it has been seen the main end product will happen for the case of the propene, the isopropyl bromide. Why? Why this thing has been happened? Yes. Now there one very important rule for your examination also, for your the total alkene preparation also, that is the Markovnikov rule. What is the Markovnikov rule? It is a very simple rule. As per this rule, it has been stated that if an unsymmetrical reagent will add to an unsymmetrical alkene, okay, if an unsymmetrical reagent will add to an unsymmetrical alkene, then the positive part of the unsymmetrical reagent will directly attach to the particular carbon atom which will contain the maximum number of the hydrogen atoms, and the particular carbon atom must be contain one carbon-carbon double bond. That means, hopefully you know, in case of the alkene, there are minimum one carbon-carbon double bond. So, if we react that particular unsymmetrical alkene to a unsymmetrical reagent, then the positive part of the reagent will directly attach to that carbon which is attached to the carbon-carbon double bond and contains the maximum number of the hydrogen. If you notice on this particular point, you can see it in case of the A. In case of the A, this carbon contains the 2 hydrogen atoms. Okay, but in case of the B, if the hydrogen atoms joined on that particular carbon, that carbon only contains 1 hydrogen atom. Due to that reason, isopropyl bromide will be our end product. Clear? It is follow the Markovnikov rule. Your question will come, what is Markovnikov rule? Write a short note of the Markovnikov rule. Okay, so it is the Markovnikov rule. And what is the mechanism of the Markovnikov rule? See, in the first case, similar hydrobromic acid dissociate into 1 electrophile and 1 nucleophile. Okay, in the second step, that is the very important, you can take a screenshot of this particular, hopefully you can see it. Okay, it is the stability series. The most stable is the tertiary carbonium ion, next stable is the secondary carbonium ion, and most unstable is the primary carbonium ion. Okay, so tertiary carbonium ion, as per Markovnikov rule, tertiary carbonium ion is the maximum stable, next is the secondary carbonium ion, and primary carbonium ion is the most unstable. Okay, so as per this rule, the proton, that means the electrophile, attacks to the carbon-carbon double bond and produce 1 primary carbonium ion and 1 secondary carbonium ion. But as per the Markovnikov rule, the secondary carbonium ion, that means the 2 degree carbonium ion, will be more stable than the primary carbonium ion. Okay, so in the next step, the secondary carbonium ion, which is the most stable, to attack to the bromide ion and finally forming the isopropyl bromide. Okay, it is the Markovnikov rule. Next, is the Markovnikov rule will be always true? There will be no controversy or the no opposite thing happen of the Markovnikov rule? Yes, the opposite thing will be happen, and that will be come on the peroxide effect. See, on 1933, one American scientist, M.S. Kharash, has invented it that if hydrobromic acid is react to an unsymmetrical alkene in presence of an organic peroxide, then the opposite thing of the Markovnikov rule will be happen. What opposite thing? Suppose if propylene react with the hydrobromic acid, as per the Markovnikov rule, if there will be the no peroxide, then what will happen there? Then there the isopropyl bromide will be forming as per the Markovnikov rule. But as per this scientist, M.S. Kharash, has said, if there any organic peroxide has present, then its anti-Markovnikov phenomena has been happened, and due to that reason, N-propyl bromide will be the major end product. Why this thing has been happened? This thing has been happened, there will be one mechanism, I will describe it later. First, remember one thing, this phenomena, this anti-Markovnikov phenomenon is known as the peroxide effect. What is the anti-Markovnikov phenomena? When hydrobromic acid will react, or not only hydrobromic acid but also any halogen acid will react with any unsymmetrical alkene in presence of organic peroxide, then it will produce the anti-Markovnikov product. It is called the peroxide effect. Okay, so what is the mechanism? See, in the first step, the peroxide, because remember here the organic peroxide plays the vital role. Okay, so at first step, peroxide dissociate to give the alkoxy free radical. Okay, and some heat should be required there. In the next step, the alkoxy free radicals will react to the hydrobromic acid and forming one bromine atom. Okay, in the third step, the bromine atom reacts to the propylene to give, similarly same as the Markovnikov rule, Similarly, here also give one less stable carbonium ion, one less stable free radical and one more stable free radical. And here is also same the Markovnikov rule. The most stable is the third degree free radical, next is the second degree free radical, and finally 1 degree free radical will be the less stable. Okay, 3 degree free radical is the most stable, 2 degree is the second, and 1 degree is the less stable. And due to that reason, here also it is forming 1 degree free radical and 1, in case of the A you can see it, 1 degree free radical will produce, and in case of the B 2 degree free radical will be produced. So due to that reason, 2 degree free radical directly attack to the HBr molecule in the last step, okay, and forming the N-propyl bromide, normal propyl bromide, and this free bromine atom will come back to the second step. This bromine atom will come back to the third step again, and the reaction will continue again. Okay, it is the peroxide effect. Next we will study the addition of the hypohalous acid. Hypohalous acid, here also in case of the unsymmetrical alkane, here also Markovnikov rule has been followed. Okay, so in case of the hypohalous acid, here the hypohalous acid reacts with the alkene and forming finally the halohydrine finally. Okay, the alkene halohydrine has been produced. So here I have given you the two examples. In case of the ethylene, when it is react with the hypochlorous acid forming the ethylene chlorohydrine, and in case of the propylene, when it react with the hypochlorous acid, it is forming the propylene chlorohydrine. Clear? Next, the reaction with the sulfuric acid. This reaction is also known as the hydration. See, here actually the main thing has been happened. The alkene reacts with the water in presence of the sulfuric acid, and some heat should be required, and it is produces the alcohol. It is the main reaction, because from the name you can understand it is the mainly hydration. Hydration means reaction with the water. So in the final reaction, what will be happen? The reaction of the propylene react with the water and forming the ultimately isopropyl alcohol and sulfuric acid. Okay, this is sulfuric acid and water. Okay, propylene. But this thing will be happen in the two step. First step, propylene reacts with the sulfuric acid and forming the isopropyl hydrogen sulfate, and in the next step, isopropyl hydrogen sulfate will react with the water and forming finally the isopropyl alcohol. See, first step, propylene reacts with the sulfuric acid and finally forming the isopropyl hydrogen sulfate, and in the second step, isopropyl hydrogen sulfate will react with the water and forming the isopropyl alcohol. Okay, and this reaction for the unsymmetrical alkane, Markovnikov rule is also followed. Clear? And today our last topic is the alkylation. What is the alkylation? Alkylation means when alkenes reacts with an alkane, then the finally forming the isooctane. Okay, that means alkene reacts with the alkane and forming the isooctane. This method is called the alkylation. Here I have given the example in case of the isobutane and isobutene. Okay, and final product is the isooctane. And remember one thing, here we used in presence, we has been occurred the reaction in presence of the either sulfuric acid or hydrofluoric acid. The reaction will be happening in presence of the either sulfuric acid or hydrofluoric acid. The reaction of the alkane with alkene, final product will be the isooctane. Clear? This method is known as the alkylation. Okay. All things you can get in the Val and Val. Okay. Study from there, and if you feel any doubt, you feel free to contact me in my WhatsApp group. Okay, and next day we will definitely complete the chemical properties of the alkene. Okay, Study well, students. Goodbye. Take care.